Hello, my name is Ivan, and this is my video for the problem situation of analysis of signals and systems. So, well, we shall begin. First of all, this was made with Axel Armando, my teammate, and well, this video is gonna be divided into 5 different segments. First, the objective experiment, the first, the second, and third experiment, and finally some conclusions. First, the objective is the main objective of this project was to develop a system that fed with different voice samples is able to recognize differences between them via pattern recognition, and well, this is achieved by different processes that read and process the voice patterns and signals. This was made by the MATLAB code. The code is supposed to record and then plot the different uh, parameters that we ask so that we can recognize the difference between each voice sample. Well, the first experiment is a simple recording, one single recording. This is mine. In this case, we have the first one, that is the waveform that is shown counting from 1 to 5, since the length of the recording was 5 seconds. Next, we have the frequency that's graphed in red. Next, an histogram of the voice recording, CDF and PDF plots for the voice recording that are shown together. Then the spectral density, and finally the autocorrelation, then the Fourier transform from this autocorrelation. Here we can see that mainly the waveform is quite defined, and you can see when there's something being said and where it's not. The frequency, the different levels, and where's the magnitude. Also the histogram, you can see when the highest point is, as well as for the Fourier transform, you can see a clearly defined pattern that's way similar to the frequency and to the spectral density. Well, next we go to the second experiment. This is my second experiment. This is done taking 30 different samples. They are averaged and then they are plotted. As we can see, for the waveform, there's no much clarity. It's mainly just a lot of noise, so we cannot tell, or we cannot take it as a solid point for comparison and for voice recognition. However, when we talk about frequency, we talk about the Fourier transform and the average spectral density, we can clearly see similarities to the voice recording was only once instead of 30 as this one, since this is this is made by averaging the values, as I previously said. Also, we can see clear differences between the CDF and PDF voice recordings. This is mainly because some data was lost while averaging. And one thing that's good to note is that the histogram is quite different, since the last one was made by the 10 times 4. This one goes up to 10 times 5, which is much higher. However, we can say that after quite some consideration, we could probably use many samples, average them, and then use it to recognize certain patterns and to recognize an individual. And when we go to a third experiment, in this case, I'm gonna compare the single recording of mine to a woman's. So on the left we have the women's, and on the right we have mine. We can clearly see that's much dense in the lower frequencies. However, when we go to the higher up, we can see not much difference. However, when we talk about lower frequencies, which usually mean deeper voices, you can clearly see that's a difference. And this is shown also in the Fourier transform, which I believe is one of, also apart from the frequency, it's one of the biggest comparative points for the experiment. Finally, well, I can conclude that even though it's possible to make a voice recognition system using the tools we had at hand, it's not quite ideal, also, as well as the conditions were nothing but ideal. First of all, we could try and argue that a better mic could be worth it. However, with just a sample of the same voice recording and the same message, it's not gonna do much for the voice recognition. It's however it can be done. And well, that would be all from my part. Thank you.